Okay, so let's do another example. Let's try one more. Can you tell me, basically, is almost exactly the same type of example, but suppose I want to know the derivative of e to the x to the 10th, like that. Yeah. Can you do that? Or let's make it a little different. Let's say plus 8. Okay, let's make that. Suppose you want to know that. How do you find the derivative of that? How do you find that? So it's hard to do unless you first try to see that as the composition of two simpler functions. So I'd like to write f as an h of k of x, and in that case I'll need to know what h is and what k is. So what would be the outside function here? The h function? E to the something, right? E to the x. And what would be the inside function? Okay, and then you could do this using the chain rule. Okay, so then you could find this, the derivative of this. Okay? Very similar to the last problem. Okay. So, with that in mind, let's take a look at the homework problem. This one here. Okay, so what's the function that we're working on in this problem? So what is y? What is y? This is y, right? And what do we want to know about it? What do we want to know about y? We want the second derivative. Now, okay. So this one, how do we do this? What's the first rule we're going to need here? The first rule is not the chain rule. What's the function we're talking about? Okay, that's the function. And the question is, what is y double prime? What is the second derivative? Well, let's not start with that. Let's start with, what is y prime? Right? What is dy dx? Right? That's what we want to know. And what's the first rule we're going to have to use here? It's not the chain rule, but we will need the chain rule, but not first rule. The first rule is, if you recall, we had a rule like this. The derivative of f plus g is equal to, so in other words, for example, the derivative of x to the fifth plus x to the third is equal to what? The derivative of x to the fifth plus the derivative of x to the third, right? That's a rule, right? So it's 5x to the fourth plus 3x to the second, but that's using this rule, right? So it's the derivative of a sum of 2 is the derivative of the first one plus the derivative of the second one. So that was a rule that we had, which would be like this, the derivative of g plus the derivative, derivative of f plus the derivative of g. Right, that was a rule we had. So we're going to need that here. The derivative of y is what? The derivative of the first piece plus the derivative of the second piece. I'll just write that the same way. Derivative of the first piece plus the derivative of the second piece. So the first piece is e to the x, e to the minus x minus x and e to the x. Right? Okay? So we need to do that first. Well, there's two pieces now that we have to do. The right one is really easy. This piece is just what? The derivative of e to the x is what? Is e to the x. So that's not going to be hard to do. That's going to be obvious. That's just e to the x. Okay, then we have to do this one now. Now, everybody will want to say, oh, that's just minus e to the minus x. No, what will they say? No, that everybody, I don't know what everybody would want to say. I don't know, but you might think, oh, I already know how to do this. But you don't. You don't have any rules for this. This is not the same as something like this. The x is in the exponent here. The x is in the base here. These are not the same functions. So we don't have any rule for that. For the derivative of this. The only rule we have here is the chain rule, again. So I'll let you work on that right now. See if you can figure this out. What is the derivative? We need the derivative of this piece, which I'll just write it here. We need this. So can you work your way through the same kind of thing that we did over here? We started with this, and we had to write it as the composition of two simpler functions. You're going to have to do something like that here first in order to do this. Because it's kind of simpler than the other one. It kind of makes you more confused actually. Because this one actually, it's easier to see that these are like this is one function and this is another function. Here it's a little hard to see, but the same thing really. So see if you can figure that one out. What is that piece? We found this piece. We still need that piece. Try and do it yourself first. So, step one, just do step one, which means write it as the composition of an outside function called h and an inside function called k. Just try and do that first. So that function, e to the minus x, can you make an outside function and an inside function? Just do that. You don't have to do the chain rule. Just do that. So what is the outside function and what is the inside function? Okay, does anybody have the outside function? By the way, generally there's not just one way to make an outside function and an inside function. Just like, if I ask you to find the sum, give me 8 as the sum of two numbers, there's not just one answer, right? You can do 3 plus 5, but you can also do 2 plus 6. So similarly here, there can be more than one answer, although here, in this particular case, there's not really more than one answer. So what is the outside function? What is h? And what is k? What's the outside function? E to the x. And what's the inside function? Minus x. Okay, so then the derivative of this piece is going to use this rule here. So this piece, k prime is what? K is minus x, so k prime, we have two parts. So minus x, the derivative of that is what? Minus 1, right? And then we need this one, which is a little more complicated. H prime, and then we need to put k into it. So h prime is what? E to the x, and we need to put k into that, so it's e to the minus x. So it becomes this. So actually, what I said you might have guessed turns out to be right, but not for the reason that I thought you might have guessed it. Okay, so what's the answer? Minus e to the minus x. So that's this piece here. Right? That's this piece there. So that is minus e to the minus x. And this is a plus sign. Right? Okay? Okay, so we started this, this homework problem said, let's consider this function, right? And it said find the derivative. Actually, it said find the second derivative, but we're just going to find the first derivative right now. And we just did. So the derivative of this, y prime, is here. Okay? And then, but actually this problem said find the second derivative, so they have to find the derivative of this. Okay, so you can do the same thing again. And actually this piece is still going to, the right-hand side is still going to be that. And this one, if you figure it out, is actually going to be, the minus is going to come down again, the minus is going to cancel with the minus, and you're actually going to end up with this. Okay, but I'll let you check that yourself. But so the answer turns out to be what? The second derivative of this is the same as the original function. Right? Kind of weird, but it's true. If what I said is right. Okay? Anyway, you better check that. You better check that the derivative of this is this. Okay, you have to check that. Okay? So that is problem number 3 in this homework set. Okay, let's go to the next problem. Okay. Okay, this is a kind of a physics problem. So it says the position S, so S is represents the distance, or the position of a point in feet, so that's like in meters, but in this case it's in feet, is given as a function of time. So what they mean is like, you have something like a car that's moving, not a point, but a car. Okay, so you have a car that's moving, or a point that's moving. And the position, S, or you might have a stone that's falling. Okay, and the S stands for how far it's fallen, the distance that it's fallen. And the distance that it's fallen depends on the time. And that's what this says, it depends on t. And in particular, it's exactly like, according to this formula, that it falls. Okay, so suppose that that's true, in other words. Suppose that we have a stone that's moving according to this formula. Find the acceleration of this stone. Okay, so that's the question, right? Now we haven't really spent any time talking about this. I think we talked very, very briefly about it. But the question anyway is to do what? To find its acceleration. Now the acceleration may be different at different times. That's why they say, find the acceleration as a function of time. Okay? So, when you have distance as a function of t, if you take the derivative of that, that tells you what? That tells you the speed. Because, like as a kind of intuitive explanation of that, so first of all, just to make sure that we remember, what does S stand for? The distance, right? They're using S to stand for distance. And it's a function of t. That makes sense, you know, if you have a stone that's falling, the distance that is fallen depends on t. Right? And then they give us a particular formula that our stone happens to be falling according to. Okay, but it could be some other formula. But in general, we just can say that it depends on t. Now speed means what? What is speed? Speed is like miles or kilometers per hour, right? Right? Kilometers per hour, for example, right? So that's distance over time, right? Right? Distance over time. It's actually the change in distance, delta distance, over the change in time, right? Right? So, but what is distance in our formula? It's s, right? right? S stands for distance, right? So we would say not change in distance.